Hi, Peter. Where are you from? From Hong Kong?
Oh no, I'm from China.
Okay, but I'm in the Hong Kong like the Peter. Okay, is that
Right.
like the
Okay.
legal name or just the is that name in on your like the certification?
No.
Okay,
Seems like there's fewer people than yesterday.
I think yesterday. Oh, maybe we still have time. I think our class, has few students than other one.
Yeah, maybe this ranked the.
I think I just apply this job position later. I think the department already distributed other instructors to the class with a lot of students. I think I like fewer students because it's easier to handle the class, and also if a bigger class, nobody knows who you are. I think now we have 9. In our class we have 9 students, and four of you are long degree students, and I think 3 are from the economy department. Okay, like that. I just forget it. Okay, I think we can start. Sometimes the students always come late. Anyway, by my experience, some of them. Okay, by the way, did you check the Canvas? I published yesterday's recording. Does anyone check the recording or under the lecture notes I uploaded yesterday? Okay. Anyway, like I said before, I will put everything on Canvas. You can get like the course recording, the course lecture notes, and also I think I will upload later. I will upload the previous midterm exam, final exam, and you can get the quiz information, right? Like I said yesterday. Okay. So let's get started. So, okay. Okay. So I think yesterday, let's record yesterday. So we talk about the vectors. After we introduce vectors, so we introduce the addition, and difference is difference, and the scalar multiplication. I think many of you already knew this part. And finally, we talk about the dot product, like if alpha is x1, y1, z1, beta is x2, y2, z2. So now I just tell you the coordinate case, because when you're doing a problem, I don't think you care about the abstract one. Okay, for example, how do we do the addition? Alpha plus beta is x1 plus x2, y1 plus y2, z1 plus z2. Alpha minus beta is x1 minus x2, y1 minus y2, z1 minus z2. So scalar multiplication, I think yesterday I made a mistake. Okay, alpha beta is Greek letter, right? Not a Roman letter, right? Okay. Anyway, I just checked online. Okay. So it's kind of, the notation, like I said. So notation, if you use the Greek letter You don't have to add the arrow. For example, you may say, okay, I'm from US, I have to use the alpha beta. For example, if we use A, okay, it's better to add an arrow, because for English, you use the same letter, sometimes feel confused, right? Or gamma and a mistake. Sometimes yesterday I used gamma as the number, but here I gamma or lambda. These are all Greek letters. So today I'll use like a constant. C alpha is cx1, cy1, cz1, and the dot product alpha dot beta is x1, x2 plus y1, y2 plus z1 and z2. All these are called the operations, right? That's math. Okay, we do operations. After that, there is an application, right? It's called, this is very important, projection, project alpha to beta. Okay, project alpha to beta, this is a picture. Okay, this is a vector. Okay, this is project alpha to beta. So the formula is alpha over beta and divided by the length of beta, complete squared and multiply by, oh no, scalar multiply by beta. Okay, sometimes I just read multiply by, but when we're talking, we don't have to follow the very standard notation because you have to look at, watch what I'm writing, right? Like, okay, so you have to remember this. I already gave the first midterm is quiz 1. I will test you this. Okay, it's very important. The dot product is very important. If we know theta is the angle, between alpha and beta. And then we have cosine theta is alpha dot beta over length of beta times length of alpha. You have to memorize this part. It's kind of this is what we talked about yesterday. Okay, so this is what we talked about yesterday. Today, we'll talk about more operations. So what chapter is it? For 1 point. Okay, wait, let me find my lecture. Okay, I think I recorded yesterday, today. Okay, I'm recording because I forgot to record our first hour yesterday. It's my bad. Okay, so today we will continue to talk about this. It's called the cross product. Oh, just one more operation. Addition, differences, scalar, dot product are all operations. You know how, like we studied plus, differences for numbers in your high school or even in elementary school. So there is a basic question. Oh, it's kind of my lecture is kind of the question oriented style, So the basic question is, if we have a basic question is, if we have alpha, it's a vector, we have beta, a vector. Okay, now we work in R3, right? That's like I said in my first time, our working space is R3. Okay, so the problem is, can you find, let me change my color. Can you find another vector, gamma? Can you find a gamma such that gamma is orthogonal to alpha and gamma is orthogonal to beta? Or, just perpendicular to each other, per. Sometimes people just do per like this, orthogonal. Okay, it's the same. I just use this notation. Even the book doesn't use this, just make us easier. So how do we find it? Okay, so this is our question. Okay, we will answer this. Okay. So let's introduce the cross product. Cross product will answer this question. So cross product. If we have alpha, this is x1, y1, z1. If you look at my lecture, I made a mistake here, just the index. But anyway, I will correct it here. You know, the lecture notes is just for your preparation. If you can find my mistake, it means that, okay, you understand me totally. If I made a mistake, you say, okay, I'm still right. It means that you made me understand something. Okay, alpha cross product is defined as, like I said yesterday, I have an equal and add this. Okay, this or this means defined. Okay, this is cross is called the cross product is defined by this formula is y1 z2 minus y2 z1. To be honestly, I cannot remember this. The formulas. Maybe you can. The student can always memorize this. You may say why I cannot remember it, because I have another way to remember it without this. Take a look. So if we have a vector with the component x1, y1, z1, beta, the component is x2, y2, z2, and we defined this as the cross product. Just this it's called the cross product. So this is just some explanation about my notation. So this is called the cross product. I cannot memorize it because there are so many index. Probably you can. So I will teach you another way to memorize this. You can use that in the future when you are doing a specific problem. And also the other method is very important for us. Okay, so let's go to second page. So I will introduce something. If you have any question, just chat. Introduce determine net. Okay, I think my spelling is right. So let's first introduce this one. So if we have A, B, C, D like this, I write this, or some book write this, A, B, C, D. So we define this. It's a new material. Okay, I'm defining this. Okay, this is A, D minus B, C. Just cross multiplication and subtract. Okay, and then A, D subtracted by BC, like A, D, B, C. So this is you can say this is a 2 by 2 box, or this is a matrix, right? Probably some of you know this. Maybe if you don't know matrix, we just say, okay, it's a 2 by 2 matrix, goes 2. And then we introduce another one. This is A1, A2, A3, B1, B2, B3, C1, C2, C3. So how do we come? Or some book write in this form: A1, A2, A3, B1, B2, B3, and C1, C2, C3. Okay, and then how do we define this? Okay, define. You look at the first column, just A1, A2, A3. This is definition. This is A1. After you got A1, you cross the first row and the first column. What's left? B1, B, oh no, sorry, B2, B3, C3, C, no, C2, C3 is left. We already knew this, right? From the first one, right? This is 1, this is 2, right? And then for the second one is A2, there is a minus. Okay. And then you cross the first row and the second column. So we get a B1, B2, no, B3, sorry, C1, C3. And then continue for A3 is plus. Okay, you cross the first column, no, first row and last column or last column. Okay, we get a B1, B2, C1, C2. So we continue this process. Okay. Anyway, that's fine. You can continue to write it out. You can say, okay, let's continue compute this out, compute this out, compute this out. Okay, I will not show you that part because you don't even I compute out. Do you plan to memorize it? I don't think so, right? Because when you're doing specific problem, after you do this, okay, you can just continue compute it. Okay, so I'll give you an example and help you to get familiar with this. So this is an example. So this is 1, 2, 3, 4, like this. Make it faster. So by the method, okay, it's computed this. So this is 1, okay, and we get 5, 6, like this, right? The second one is 2, so minus 2, we get 4, 6, 7, 9, right? And plus 3 and 4, 5, 7, 8, right? This is a very specific problem. And then let's continue. Okay, let's expand this. This is 45 minus 48 multiplied by 1 minus 2, 36. That's right, 36 minus 42 plus 3, 33 minus 35. Okay, let's do the basic. Okay, you can use a calculator, right? But I cannot use that. Otherwise, you don't have. I don't have to count here, right? This is negative 3 plus 2. No, minus 2. What's this? Negative 6 plus 3. Okay. Multiply by negative 3. Since we get negative 3 plus 12 minus 9. Oh, it's there though. Nobody knows. I don't know the answer. I just give you any arbitrary number and try to compute it for you. Okay, probably it's right. Okay, but the method is totally okay. Okay, you can check my computation after the class. Okay, you may say, okay, why do you tell me So, like I said before, I cannot memorize this. That's a goal. I teach you one method to memorize this. Okay, so let's come back. Let's back to the cross product. So you can say this is a formula. So alpha, beta, under my first notation, okay, alpha is x1, y1, z1, beta is x2, y2, z2. Okay, so this is I, J, K. You know what's IJK? The standard basis vectors, right? And alpha is x1, put alpha here, y1 here, z1 here. This is alpha. Okay, this is beta, right? So I say alpha beta is, alpha beta is defined in this page. So now I say, okay, you can come without memorizing this. You just use this. Let me show you because just the basic computation. Okay, let me show you. So this is, okay, let's say the computation. Okay, I, J, K, X1, Y1, Z2, X2, Y2, Z2. So you may argue with me, okay, I, J, K are a vector, right? But here, everything is a number. I just say, okay, you pretend it's a number. So it's kind of the format of computation. You can use it for your computation without remembering everything. Nothing, anything. Okay, sorry. Okay, you can say, okay, let's put I here and y1, z1, y2, z2, right? And let's put a j here, but it's minus. So this is x1, z1, x2, z2. Okay, plus k is a vector. Okay, sorry. x2, y1, x2, y2. And then let's expand because we need it. Okay, so this is y1 z2 minus y2 z1. This is I, right? Minus j. So I can just put the elective inside. We get x2 z1 minus x1 z2 j. I give, because this is x1 minus 2 subtracted by x2 z1. I just switch the order, put the the elective sign inside. I think I'm right. Right. It's right. And the plus k is x1 y2 minus y1 x2, and k. Of course, you can say 1 plus 2, 3, 3, 2, 3, 3, 3, 3, 3. Add them together, both are 3. But it doesn't help, You just tell me, okay, there is some formula. You can say this is the same as the definition, right? This is very helpful. Oh, okay, you may say, no, it's not the same. It's the same. You write this is y1 z2 minus y2 z1 x2 z1 minus x2 z x1. It's very easy to make a mistake. You have to be careful when you are doing this kind of problem. If you made a mistake on the sign, of course your answer will wrong. Of course, sometimes you may write finally, you made a mistake wrong and made a mistake wrong again, and then finally you write, magic happened. Okay. So this is about the cross product. It's very important. Okay. And then, like, if we come back to our question, or my question is that, can you find a gamma such that gamma is perpendicular to alpha and beta? Okay. I will say the cross product alpha cross product beta is the gamma that we are trying to find. But you may say, geometrically, you can say, if you can find one gamma, if you find a gamma is perpendicular to alpha and beta, two gamma is automatically perpendicular to alpha and beta. Means that the answer is not unique. But in general, nobody will ask you to find O. If you find one, you can multiply a number. Together multiply by a number, you get O. It's kind of, sometimes, just like that. It's not unique, but if you find one, I thought, okay, that's okay. So let's come back. Oh, okay. So let's first check some, show you an example. Okay, that's very important. Okay, let's first show you an example, help you to get familiar with the cross product. Okay, this is very important. Okay, let me change the color. So this is very important. I think you have to memorize this. Otherwise, you cannot do the problems. Okay. So let's say now we have alpha is 1, 3, 4, beta is 1, 7, -5. So let's compute alpha cross product beta. This is I, J, K. Okay. And this is 1, 3, 4, 2, 7, -5. Okay, let's do. So, like I said, I cannot memorize this directly. Okay, but you can, I don't mind. Okay. Okay, so we get I, and this is 3. Okay, 3, 4, 7, -5 minus J 1, 4, 2, -5. If I made a mistake, just print out as strong as possible. Okay. And sometimes, you know, when I was talking and also writing, it's easy to make a mistake. Okay, and then let's continue. We get a you negative 5. Okay, let's do more. Minus a I minus j negative 5 minus 8 plus k 7 minus 6. So we get 23 I plus 30 j plus k. Oh, I hope I'm right. I'm not sure. No, 30, no, 35 minus. I think. Okay.
This should be 7, I think. 3, 4, 7, negative 5.
Let me. Oh yeah, yeah. That's why, you know, my handwriting, you know, this is 7. It's a handwriting problem. Okay, 28, that's 33. Like I said, okay, now it's right. So like I said, you know, when you are doing a problem, you have to write everything clearly. Otherwise, you misread it when you are doing the second line. Okay, it's a perfect mistake to help you. Okay. That's fine. This is the basic example. You don't have to do a lot of problem like this. You know the basic rule. And I will emphasize in this place, there is a negative sign. Okay. Don't forget this. If you made a mistake here, probably you know, your whole process will run. Why? Because this is very important for our future study. We will study integral. We will use this. If you made in general, this will be the first step. If you made the sign, you will be wrong. The answer will be, you know, after the first step. After you use this, the whole process after this step will be wrong. To me, you have to be careful. Okay. I think maybe the calculator can do this. I'm not sure because I never use a calculator for this kind of stuff. Nobody knows. Okay. So I hope you understand me. So, and then let's look at more examples. So if we have alpha and cross product itself, the solution, okay, this should be 0. It's kind of how do you think about this? Okay, let me look at it. Okay. You can say alpha cross alpha is I, J, K, X1, Y1, Z1, X1, Y1, Z1. Oh, what I'm writing. You can say this is just I, this multiplied 1. This multiplied by this. Y1, Z1 minus Y1, Z1. Right? Minus J, X1, Z1 minus X1, Z1. Plus K, right? X1, Z, no, X1, Y1 minus X1, Y1. It's the same. You can say automatically you get a 0, 0, 0. But here you have to emphasize this is a vector. Okay, because I write 0 because, you know, sometimes, you know, the scalar 0 is it's also 0 notation, but in case I misread what you are writing, or in case you made me some mistake, you just emphasize, you add an arrow. Okay, so let's write a remark. So that's what I want to say. So if we have 2 vectors, one is alpha, another is beta. So let's first look at the dot product. The dot product is alpha dot beta, or is x1 y1 plus x2 y2 plus x, no, sorry. Oh, what I'm doing? Too fast and made a mistake. Okay, this is x1 x2 plus y1 y2 plus z1 plus z2. Alpha is x1 y1 z1. Beta is x2 y2 z2. And 2 is the cross product. This is alpha cross beta by the formula. You know, I use, okay, in general, I will write it in this form. x1, y1, z1, x2, y2, z2. Because when I doing problem, you just compute this. Okay. Okay. So you can say this is a scalar or a number, right? And then this is a vector. By my experience, every year, I think I did this course, I think 4 semester, every time there are always few or some students, 1 or 2 students, finally he got the cross product is a number. You may say, how? I can say magic is always happen for the students, you know. How? For example, like the wrong process, you know, every time when the students get this process, you cannot, it just is quite hard to imagine this. He gets this and finally wrong, he add, okay, this answer, he continue this process and add this and add 1 and okay, oh, magically we get a number is 29. You know, I think that there is no professor teach you this, right? I cannot explain why. This is a vector. Don't do this. Clear? Give me a feedback for this. Don't do this. Means that you listen to me what I emphasize. This is a common mistake. Don't do this. Okay. So this is a vector I only emphasize. And also the third one is scalar prime. I was made a mistake because, you know, recently I say very this like the alpha. So if I made a mistake, just tell me. This is say x1, say y1, say z2. It's also a vector. Okay. So this is kind of the operation I teach you. So now let's come back to our geometrical question. Okay, now back to our original geometrical question. Geometrical question. We have alpha, we have beta. Find wait. I put it. I think it's better to put a. Oh, sorry. What happened? Beta. No COVID. You know, I already get the vaccine. Hope it works. How do we find a gum? So, okay. let me get some water. Okay, sorry. Okay, let's come back. Sorry for this. So there is the theorem. This alpha cross beta is a vector. This is okay. I just use the notation because I want to use less English. Is perpendicular to alpha and alpha cross beta with beta. You know, that's why, because, you know, in France, I think in France, there is a kind of mathematics school. It's called the Bourbaki. In that group, the students say, okay, in the future, we will develop math without any language, without like the English word, any language, like the Chinese or Korean, just without language, just the mathematical notation. It's kind of, that's the goal. Okay. Because, you know, the language has its own restriction. You know, if you use more language, you know, it will affect your thinking. Okay. So This is the theorem. It's kind of the cross product is perpendicular to alpha and beta. By this theorem, we can choose or pick gamma as alpha cross product beta. Gamma is not unique, or you may say, why not? Why or gamma is any number C alpha cross beta. It's the same, but in general, we just choose one. Okay. Anyway, that's fine. Of course, C cannot be zero. Right. Otherwise, you get the zero vector. Zero vector doesn't give you any information, just zero. Okay. So you may say, okay, how do we prove it? How do we know this? You know, this is just a computation. Like I said last time I said, okay, so let's look at the proof. You know, just tell me the idea. I will not prove it. Okay, let's see it. So if we want to prove this, oh, sorry, what am I writing? If we want to prove alpha cross beta is perpendicular to alpha, what do? So we try to check alpha beta and check alpha dot alpha. It's zero or not. So just check this. Okay, let me check one for you. You can do the same. Check alpha cross beta dot beta. So let me check. So let me check. So alpha cross beta dot alpha is ijk x1 y1 z1 x2 y2 z2. This is a vector, and then I just put alpha here. Let's first compute this out. Okay. So this is just, let me first, is y1 z2 minus y2 z1 dot, okay, just j. This is the first component. I just use, you know, write the word, you just memorize that formula for this. Otherwise, I have to explain them more every time. So, and then we get x2 z1 minus x1 z2 and x1 y2 minus x2 y1. Okay, look at I y1 z2 minus y2 z1. That's this, and then j x2 y2 y z2, right? X2 is positive, but there is a sign. X2 z1, right? And x1 y2 z2 and y2, no, x2 y1, like this, and then use the dot product x1 y1 z1. You can see you multiply them together. So let me do it. Okay, x1 y1 z2 minus x1 y2 z1 plus y1 x2 z1 minus y1 x1 z2 plus x1 y2 z1 minus x2 y1 z1. You can say x1 y1 z2, x1 y1 z2 cancel out. x1 y2, find x1 y2 z2 cancel, right? This cancel out with this. So finally you get a 0. Clear? Hope so. Yeah, I checked one. You can check as a homework or some, you know, you can check alpha cross beta and beta. You just replace x1 we replace alpha by beta, or rest of part of the same. You get this. So this is very important. Okay. So you get a vector gamma, which is a cross product of alpha beta, which is perpendicular to alpha and beta, or continuously, we can say, because we know if we have two vectors that together, starting at the same point, this two vector can span a parallelogram, right? A parallelogram. It's kind of okay. This two vector will span a plane, and of course, two vector can span a plane, and also if we remember the length, you can get a parallelogram, right? Parallelogram. Okay, the problem is that, okay, we can say gamma is perpendicular to the plane spanned by alpha and beta, right? Spanned by alpha. And also, the alpha beta can automatically produce a parallelogram. How do we compute the parallelogram? Here, so this is the question. How do we compute the area of the parallelogram? Not the area of the plane. You cannot compute the area of the plane because it's infinity, right? Infinity big. Okay. So let me continue more. Okay, let me save it. So, okay. So let's continue. So there is a theorem. So let me change the color. So the theorem says, okay, we have alpha cross beta, the length of the cross product of alpha and beta is alpha beta and times sine theta. Here, theta is the angle between alpha and beta. This is very important. Okay, just like this. So you may say, okay, let me show you how do we. It's hard to prove it, but I will tell you the idea. But even though I will not teach you the whole process, you just check both sides are the same. Okay, let me check. So if you look at the left hand side, right? So you first, you get what's alpha. You get what's alpha. And so what's the cross product of alpha beta? This is just the y1z2 minus y2zy. I just copy the lecture notes, okay, because I cannot memorize it. x2z1 and x1 y2 minus x2 y1. So this is a vector. You just compute. You can we just check this. We just check this. Okay. And then the left hand side, if this is right, the theorem is right. So we get this is the length. So you get this out and just complicate, you can use a calculator to do this, but anyway, the idea is quite clear. And then let's look at the right hand side. The right hand side is kind of complicated, but anyway, it's still fine. The right hand is alpha squared and beta squared and sine squared. The problem is that how do we deal with this? This you have to memorize, have to know this is sine squared plus cosine squared is 1, right? So you use this is r squared beta squared and y minus cosine squared. But you may say, I don't know the cosine squared. No, you know it, right? You have to know it for this course. This is alpha, beta, and alpha, beta, cosine beta. And then you plug in this alpha squared, beta squared, minus alpha squared, beta squared, cosine squared, and then this is alpha squared, beta length squared, minus alpha squared, beta squared, and cosine, this is alpha dot, this is a number, and alpha, beta, right? This is the left hand side, this is right hand side, and then finally you plug in x squared is x1 squared plus y1 squared plus z1 squared, beta squared is x1 squared. Okay, anyway, I can continue simplify it. Okay, this is just alpha dot beta, right? This is a number, this beta. Okay. I think I'm right. And y2 squared plus z2 squared. And then you compute alpha dot beta. This is x1, y1 plus x2, y2 plus x. No. What am I doing? x1, x2, y1, y2, z1, z2. And then you plug in everything into this formula. Finally, because the proof is not required, I just show you the process. Okay, finally you can check, or you can get this, and the third is check. The third step is check. Okay, magically the right hand side is the left hand side. So the proof is done. Is the whole process clear? I hope so. No reaction. Okay. So this is the process. If you have, of course, if you want to understand this course very well, or use in economy or other field, it's very important. I think in economic class you will use it sometimes. Okay. You always say, okay, something is perpendicular, something that's like a maximum way the people can earn more money. Kind of like that. Okay. So this is about the length. You may say, why do you do this? Why do you tell me that? Because let me write a remark. Because like we said, a vector has two sides. The first one is direction. Right here, alpha cross beta is perpendicular to alpha, r cross beta is perpendicular to beta. This one, this result is kindly telling us, okay, the direction is this, perpendicular to alpha and beta. The second one is the magnitude. It's hard. Anyway. And then, okay, this is this, and this. Theta is the angle. Okay, I just write this. You know what I mean by that. Angle, alpha and beta. Okay, it's kind of now I already tell you, okay, for vector, we know the direction and the magnitude. That's fine. Yeah, we know everything. And also continually, we know. Okay, I think I have to give more example. Okay, okay, let me give you one theorem. It's about the theorem. Okay, I can write okay, theorem or formula. Okay, sorry. Okay, we say, okay, if we have alpha and also we have beta, this is alpha, this is beta, and then alpha beta produce a parallelogram, right? So now the problem is that how do we compute the area of the parallelogram? Okay, so the theorem or the formula says, okay, the area of the parallelogram is alpha cross beta, like this. This is the formula. Okay, you may say, how do I know this? If you recall what you know in your high school, this is very obvious. If you know this theorem. Oh, why it gets so bold? No, that's fine. So let me do more. So this is the theorem. So let me show you. So check. So let's look at the right hand side of this term. And then let's look at the parallelogram you know in your high school. So like this. This is I think my parallelogram. Anyway, you know what I mean. This is I write this. This is okay. This is alpha. This is beta. So we know how to compute the area of the parallelogram. This is the base, right? This is the head, right? We know the area should be the length of the base multiplied by h. H is the number, right? What's the h? In this right triangle, h is the length of beta times sine theta. So it means that the formula is, I think you may know this, sine theta. And then by the theorem, we get the formula. Okay. The parallelogram surrounded by two vectors, alpha and beta. For it, the area is just the length or the magnitude of the cross product of alpha and beta. Is it clear? So this is the area of the parallelogram spanned by alpha and beta. Okay, that's fine. So I think this is the cross product I plan to see, and then now I'll give you an example. So let me save it. So go to next page. 1 hour passed. It's so fast. Okay. Anyway, we still have time. So I will not 100% follow up the how to say the schedule. Sometimes I may be faster because we have less students. In general, I plan on Friday. I will ask you guys to show me some problem because we have only 9 students in our class. You know, give you a chance to practice because I know your problems and then I can, you know, very happy. Don't feel pressure, you know, just to give you a chance to practice. Okay. So let me look at more examples. Okay. So the example is that, okay, the problem is that, okay, find a vector. Find a vector which is perpendicular to a plane. Okay. The plane has 3 points, P and 1, 4, 6. Q is -5, 2, 5, -1, PQR 1, -1, 1. So it's kind of the problem is that, okay, we have 3 points. The 3 points are in the same plane. Okay. This is P, Q, R. So find a vector, which is perpendicular or gamma. Okay. Which is perpendicular to this plane. Not a place, plane. Okay. So how the method is fixed? Like I said, if you record the cross product, you have two vector and then okay. If no, you only have to find a vector which is perpendicular to two vector in this plane, right? Because the two vectors determine a plane, right? That's the plane geometry in your middle school. Okay, no, in middle school, not elementary school, primary school. Okay, how you can pick any one. For example, I can fix P. We consider PQ. We get a vector, and we can say the PR. So we can say PQ is you use PQ is negative 3. This minus this 1 negative 7. PR is 0 negative 5 negative 5. Right? We get two vector which are PQ and PR, right? Two vector. This one, and then this is our alpha or beta, and then we can compute PQ. Oh, sorry, I have to come back. Okay. PQ cross product PR, and then I, J, K, negative PQ 1, negative 7, 0, negative 5, negative 5. So let's expand it. This is I 5 minus 35 minus J negative 3 multiplied by negative 5 minus 0 plus K negative 3. I think I'm right. If I made a mistake, just point it out. Negative 5. No. Did I make a mistake? Yeah, it's right. It's right. Nothing wrong. Minus 0. And then finally, we write out of this is negative 40, right? Negative 15, positive 15. So means that the vector is, so the vector gamma is 45, this 45. This is just one answer. One format of the answer. You may say, okay, how about if I write a gamma is, you multiply by 5, you get like this. Both are right. Okay. Or you said gamma is 8, 3, negative 3 are right. Here? That's fine. Okay. And also, I can ask you more. Find the area of the parallelogram defined by PQ and R, PQ and PR. So if here PQ and PR expand a parallelogram, right? How do we compute the area? The area is just you have to use this. You cannot say, okay, let me first divide it by 5 and then compute the length. No, you cannot do that. You have to use the original number. Okay, be careful. Okay, because sometimes the problem is asking, okay, find the unit vector. Yeah, you cannot say, okay, after I find the unit vector and then we compute that. It's always 1. Okay, and then the answer should be area 40 squared plus 50 squared plus 50 squared, right? And then you use your calculator, you get the answer is like this plus 15 multiplied by 15. I think is okay. I think is this. Anyway, This part is not important. You just use a calculator to get the answer. Okay, that's fine. I think that's 3 examples about the cross product. And any question about the cross product? Okay, finally, I will introduce about more formula about the, okay, more or properties for cross product. Okay, cross product. Okay, let me change the color. So the first one is, okay, finally I'm emphasize. This definition for the cross product only apply in R3. You can not move this to R4 like in the higher dimension in the future. Anyway, just in R3. Okay. So the first one is, okay, what happened? So the first one is I, you know what's I? J is K. This is the first one. J, K is I. K, I is J. Okay. J, I is elective I. K, J is elective I. Elective K, sorry, the previous one. I cross product K is elective J. It's kind of if you switch the order of IJ, you know, the no, anyway, just for this in the future, I think later I tell you more. So, and then this is the first, third one. Alpha cross beta is negative beta cross about alpha. It's kind of the rule. If you know one, automatically one combined. If one is combined with 3, you get 2 automatically, right? Okay, let me say. Oh, God, let me say more. Okay, 4. So if we have lambda alpha cross product beta, this is alpha cross lambda. Oh, sorry, I will use C. My bad. C. Okay, just raise it because it's faster. So C alpha cross beta is alpha cross C beta. Is C alpha cross beta. Right, this is the formula. Okay, and then 5 alpha cross beta plus gamma is alpha cross beta plus alpha cross alpha. Gamma, sorry. What are you doing? 6th one is alpha dot beta cross beta gamma. Oh, this is kind of hard. Yeah. Oh, this is not that hard. It's just alpha cross beta dot gamma. You cannot change the order. You know alpha beta. You have to follow this. Anyway, this one is okay. You for example, you can first compute the cross product for beta and gamma, and then compute the dot product. You can first compute the dot product, the cross product of alpha beta, and then gamma. Okay, you may say, okay, why not? Why not alpha cross gamma and then dot beta? It's the same, the answer. Why? Because you can write alpha dot beta cross alpha as alpha dot negative alpha like this, right? And then negative, you can put this outside and negative alpha dot this. Just switch the order, right? And then use the formula. It's alpha, this, and beta, but there is a sign. You know, anyway, I am not required to memorize all because you can remember the previous formula automatically. You know what's the formula. But really, without switch the order, you just switch, you know, the dot product and the cross product. Clear? So this is now last one. So if alpha cross beta cross gamma, so this is alpha dot gamma beta minus alpha beta gamma. So in general, this formula is important, but in our course, in general, we will not give you a problem involves like the 6 or 7. It's kind of, but it's very important for your study. Okay, it may use in other fields. Okay. So this is all the properties about the cross product. Okay, probably I can add the other one is, anyway, put it all together. So this is perpendicular to alpha. This is perpendicular to beta. I just put it all together, help you to memorize it. Okay, alpha cross beta, okay, is this, and sine theta. Theta is the angle, and the area of the parallelogram. Okay, I think that's all about the cross product. Okay, I will not show you the proof, but I will help you understand it. Okay, so this is called the skew. Okay, skew symmetric. I just forgot the name. Okay. Sometimes I have to switch everything into English because we studied this. I studied this in Chinese. Okay, this is about the distribution. No. Okay. This is kind of, you can say this is kind of associated law or associated law. Okay. Oh yeah. I think no limits for other one. Okay. I think this is all about the cross product. But anyway, we will not stop today. I will continue to talk more. Okay. So, but for the quiz, for the first quiz, we only test you up to cross product. Okay. So the quiz 1 will test you until this place. Okay. This is Q1 proper. Okay, solve it, and then I will stop recording